Welcome back, students, to the chapter Haloalkanes and Haloarenes. This is a chapter for class 12, and in this part we are going to see about the nomenclature of mono-haloalkanes. So we have seen haloalkanes, what are haloalkanes and what is a mono-haloalkanes. It is nothing but a haloalkane that contains one halogen atom. So haloalkanes that contains only one halogen atom. This is what we are going to see, how to name such compounds. So to begin with, as we have said in the last part, while naming monohaloalkanes, both forms of naming are commonly used. One is common naming, the other one is the IUPAC naming. So the major difference while using these two forms is that they too treat parents in a different way. So in common naming, halide is the parent, whereas in IUPAC naming, alkyl group or the hydrocarbon part is the parent. Clear? Again, in common naming, halide is the parent, whereas in IUPAC naming, alkyl group is the parent. In common naming, alkyl is a branch, whereas in the IUPAC naming, halo serves as a branch. Clear? So that's the basic difference between common naming and IUPAC naming. So let's see the first compound. So we have CH3CH2. So which is the alkyl part? So I will draw it. So this is the alkyl part, and Br serves as the halo group. Now for naming, I should number the carbon atom, the longest chain carbon atom. Here longest chain is means this, straight away you will get this as the longest chain. While numbering, the branches must get lowest number. So here the branch is bromine. According to IUPAC, branch is bromine, or the functional group is bromine. So it should get the lowest number while numbering. So I should start numbering from here, isn't it? I should start numbering from here, starting 1, 2, 3. So if I on the other hand, if I number from here, if I start numbering from here, bromine will be having, if I am numbering from here, bromine will be having 3. The carbon attached to the bromine will get 3. But since I started from here, bromine has got the lowest number. So it is important to note that whenever you are numbering, the branches must get the lowest number. So now bromine has the lowest number. So what will be its IUPAC naming? So IUPAC, in which you have to mention first the halo group. So it is bromo. Instead of halo, I can write bromo here, in this case bromo. And I have to mention to which carbon atom it is attached to. It is attached to 1. So 1 bromo. Then I have the alkane, which is the alkane, 3 carbon atom alkane is called propane. So it is 1 bromo propane. IUPAC name is 1 bromo propane. In the case of common naming, I have to first choose the alkyl group as a branch and the halide as a parent. So here bromide is parent and propyl is the first name. So when you are trying with this, you will get normal propyl. Why it is normal propyl? Because it's a straight chain propane. So such branches are called normal propyl. So here the alkyl group is a branch, so it is normal propyl, and I have the parent bromide in common naming. I guess it's clear for you. Let's move on to the next compound then. So here I have a compound in which bromine is attached to the second carbon of a propane. So second carbon of a propane. So what will be how will I number it? So I can number either starting from here or starting. In both cases, bromine will get the will get the number 2. So we can choose either numbering. So what will be the IUPAC name? 2, because it is attached to the second carbon atom, 2 bromo propane. So it will be like that, 2-bromopropane. So whenever you are writing IUPAC name, first thing what you have to notice is the IUPAC name is a single word. Clear? There should not be any space between the names. Second thing is, whenever there is a number and alphabet, you should separate them using hyphen. So 1-bromopropane, here 2-bromopropane. You can start with the capital letter, but in between there should not be any other capital letter. Like propane, should be the P should be always in small caps. Clear? In small letter. Now, what will be the common naming for this compound? So when we were studying in the introduction part, we were seeing certain special branches that were accepted by IUPAC. This is one such branch accepted by IUPAC, but here we are looking for common naming. Anyway, in the same way, it is a special type of branch which we have already learned in the introductory class. So what is the name of this branch? It is called isopropyl branch. So in common naming, alkyl group is treated as a branch. So I can name this branch as isopropyl, and the parent is bromide. So what will be the common name? Isopropyl. So if you recollect the introductory part we took, in that we have learned this as a special type of branch that is accepted by IUPAC, whose trivial name is accepted by IUPAC. So in common name we use that branch, that is isopropyl bromide. Clear? So if it is clear, we are moving on to the next compound, and you can see in this compound there are total of 5 carbon. While naming, you should find out the longest chain, unbroken chain. So let us start looking for the longest chain. If I count like this, there is 3. If I count like this, there is 3. If I count like in all directions, there are 3. So what I have to be careful is I should include bromine in it. While numbering, bromine must be included, or maximum branches must be included in that number. Clear? So from which direction should I start numbering? If this is the chain that I chose, I should start numbering in a way that branches should get lowest number. So let us see. So I'm starting from here, 1, 2, 3, or I can start from here as 1. So if I start from here, branches will be, one is bromine, the other one is 2 methyl branches here and here. So here there are 2 branches, so that will be equal to 1 plus 2 plus 2, which is equal to 5. So if I'm starting from here, I will get branches, if I'm taking sum of the branches, 5. On the other hand, if I am starting from this direction, branches will be on 2 plus 2 plus 3. So branches will be, if I'm counting from here, on the second carbon atom you have 2 branches, 2 methyl groups, then 1 on the third carbon atom. So the total amount, the total sum will be 7. Which is the lowest? This is the lowest one, so I will prefer that numbering. So I've preferred this numbering from here, which means that on the first carbon I have bromo, on the second carbon I have 2 methyl group, which means dimethyl. 1 bromo, 2, 2 dimethyl. Which one will I give first as a branch? The one coming in first in the alphabet. So methyl M and bromo B. Definitely it is bromo. So the name will be like this. 1 bromo, separating the alphabet with the number, hyphen. Numbers are separated using commas. 2, 2, because we have 2 methyl branches. To show that it is methyl, we call it as dimethyl, and the longest chain is 3 carbon atom propane. Clear? Now in common naming, in common naming, this as a whole is taken as a branch, and this is the parent. So we have bromide as parent, and this again we have studied when we were looking into special branches. There are 5 carbon atoms, so it is pentane, and it has the shape of neopentane. So we call it as neopentyl bromide. Call it as neopentyl bromide. Clear? Neopentyl bromide. So we have seen this neopentyl group when we were discussing that there are certain branches that are accepted by IUPAC. Clear? Now let us look into more examples. Here I have 4 carbon atoms attached to a bromine. So 4 carbon atoms means which is butane, and the bromine is attached to the first carbon atom. So I can call its IUPAC name is 1-bromobutane. 1-bromobutane. And when it comes to common naming, this is the branch, so it is normal butyl. It's normal butyl group because it is 4 carbon. So normal butyl means it is straight chain without any branches. So it is normal butyl bromide. I hope it's clear for you. Next, I have a compound. Now this time it is chlorine, and the chlorine is attached to a butane, and it is on its second carbon. So IUPAC name will be like this, 2-chlorobutane. It will be like this, 2-chlorobutane. Now if you remember in the introductory class, this, if you are treating it as a branch, when it comes to common naming, if I treat this as a branch, this chlorine is the parent, then the name will be chloride, and the branch here the parent is attached to the secondary carbon of butane. So secondary carbon of butane, so I can call it as, how I will call, secondary sec-butyl chloride. Sec-butyl means secondary butyl chloride. So in the introductory class we have seen this special branch which is accepted by IUPAC. Now next, the third one. Here again I have 4 carbon atoms in total. So if I am looking for IUPAC, if I look for IUPAC naming, I should start counting so that branches must get lowest number. So if I am counting from here, 1, 2, 3. If I am counting from here, fine, the branches will get the values 1 plus 7, 1 plus 2, that is 3. But as if I am counting from here, it will be 2 plus 3. So which is the lowest sum? Lowest sum is counting from here. So what is the name? On the first carbon atom you have bromine, and the second carbon atom I have the methyl group. So 1-bromo-2-methyl. Bromine is given first because of its alphabet B, which comes before methane. So it is like this, 1-bromo-2-methyl propane. 1-bromo-2-methyl propane. So you should also write this with a pen and a paper and try to follow it. It's always advisable to write when you learn organic chemistry. It's just like doing maths. Okay, so what is the common name here? So again, bromide is the parent, and bromide onto the parent, it is the butyl group that is attached, and it is the primary carbon atom of butane, which is not a normal butane. Primary carbon atom of a butane which is not normal. So we call it as isobutyl, isn't it? So this is isobutyl, the branch that we have learned. So bromine, the attached carbon is primary, but it is not normal normal butyl is this one which we have already answered. So this is butyl with primary attached to it, and it is not normal, so it is isobutyl bromide. Isobutyl bromide. Now moving on to the next one. Again, this carbon altogether we have 4 carbon, and bromine is attached to this one. If I am looking for the longest chain, I can give number like 1, 2, 3 or 1, 2, 3. So 3 carbon atom is the longest chain. So it is propane. In IUPAC naming, the parent is propane, and the branches are bromine and methane. Both are attached to the second carbon atom. So it will be 2 bromo, 2 methyl propane. 2 bromo, 2 methyl propane. Clear? In IUPAC naming, again bromide is the parent and it is attached to a carbon atom. Again a special branch. So this is again butane, and in butane bromine is attached to the tertiary carbon atom. Tertiary carbon atom. So how can I name it? It is tert-butyl bromide. It is tert-butyl bromide. This is again another branch, special branch which we have learned when in the introductory class. Okay, so it is tert-butyl bromide. Okay, so I hope you understood it. We were dealing with the special branches until now. So next is draw and give IUPAC name of all the isomers of, we have a 5 carbon alkyl bromide, mono halo alkyl bromide. So IUPAC name of all the isomers of C5H11Br. Also classify them as whether it is these isomers as primary, secondary and tertiary. Clear? So we will start with the first simple 5 carbon haloalkane. So let us start with that. So first one will be 5 carbon atom means CH3, CH2, again CH2, then CH2. So we have 4 carbon completed, and finally we have CH2Br. So 5 carbon atoms, 1, 2, 3, 4, 5 and Br. Clear? So when Br comes here, CH3 will turn into CH2. So it is a pentane. The parent alkane is pentane and bromine is attached to the first carbon. So 1 bromopentane. So let us see that now. Yes, we have the same structure here. So it is 1 bromopentane. And if you're looking into the degree, bromine is attached to a primary carbon atom. What is a primary carbon atom? Primary carbon atom is an atom that is attached to, that is having either 0 or only 1 carbon-carbon bond. There is only 1 carbon bond. So terminal carbon atoms are always primary. Clear? So this is attached to another only 1 carbon atom. So it's a primary carbon atom and the name is 1 bromopentane. So if we are considering only the straight chain of 5 carbon atom, what are the isomers that is possible? So bromine might change the position, right? So here bromine is in first carbon. Let's assume that bromine changes its position to the second one. So like this, bromine has changed its position from 1 to 2. So this is another isomer having the same molecular formula, isn't it? So we have 2 bromopentane, but this time the carbon is having second carbon is a secondary carbon. Why? Because carbon is attached to this carbon and to this carbon. So since it is having 2 bonds with 2 carbons, each bond with 2 carbons, we call it as secondary haloalkane. Clear? Now, so we have now the second one. Now if I am again moving bromine to this side, will I get a new compound? Yes. So I have moved bromine one more place to the left. So I have 3 bromo and again secondary. 3 bromopentane and again this carbon is secondary because it is attached to two other carbon atoms. So, and if I move one more place, it is same this compound. If I move one more place here, then I have to start counting from this side, isn't it? So it is 1, 2, which is 2 bromopentane. So the two possible straight chain molecules are 1 bromo, 2 bromo and 3 bromo. 3 possible. In this, 1 bromo is primary, whereas the rest of the two are secondary. Now, next what we have to consider is, try to imagine that bromine remains here and one of the CH2 or one of the CH3 group is branched. So let's take that for example. Here you can see straight chain is 4. 1, 2, 3, 4. And bromine is attached to the end like this, and whereas CH3 is branched. CH3 is placed on the second carbon atom. So we have two branches. One is CH3 from second carbon atom and bromine from the first carbon atom. So what will be the name? 1 bromo, 2 methyl butane, and it is attached to a terminal carbon atom, so it is a primary haloalkane. Now what I am going to do is I am trying to shift the position of CH3. Let us see. I have moved from second carbon to third carbon. CH3 has moved from, by keeping Br there itself, I have moved from second to third. Clear? Now if I am numbering, from which end I should number to get the lowest number? 1, 2, 2 plus 4, that is 6. If I am numbering from here, 1 plus 3, that is 4. So which I should take? I should take the numbering from here. So it is 1 bromo, 1 bromo, 3 methyl butane. Again it is primary. So you cannot move further CH3, because if I am moving to here, then it will be this compound. So there is no other option of CH3 moving. Now I will start moving Br a bit. So let us see. Not Br, I have again made another CH3 into it. I have made a second CH3 as a branch. So CH3, C, instead of one CH3 I have now two CH3, one up and one down, replacing this hydrogen, up down, and then I have CH2Br, which is again another isomer. So which means that if I am counting 1, 2, 3, which will be 1 bromo to 2 dimethyl propane. So I have 2 methyl group attached to this carbon, and on the first position I have bromine, in the second position I have 2 dimethyl propane. It is a first degree. This is the compound which we saw in the last class, famous by its name, its common name. So it is neopentyl bromide. Clear? If I draw the structure of this particular compound, it will be like this. So I will try to draw this compound. I have carbon on the center and I have CH3 onto all sides. So here it is CH2Br, and onto this side I have CH3, and to down also I have CH3. So if I am moving bromine from here to here, it is the same compound. If I am moving bromine here to here, it is the same compound. From here to here, it is the same compound. And bromine have no other option. So for this skeleton, for this type of pentane or this type of skeleton, there is only one position for bromine to remain, that is 1 bromo. So 1 bromo to 2 dimethyl propane, primary haloalkane. Now I will start moving bromine. If now the bromine is, for example, here I cannot move anywhere, there is no isomer, but here if I am placing bromine on the second carbon atom, that will be completely different, isn't it? So I have placed, moving this, I have placed So I have considered this, I think. Yes, this one. And I have taken bromine and I have placed here bromine on this carbon, on the second carbon atom, along with methyl. Instead of one bromo, now I will have two bromo, two methyl butane. And the carbon atom attached is a tertiary carbon atom. Clear? So I have compared this molecule to make this option. Here it is on the first carbon. Instead of first carbon, I choose the second carbon where already CH3 is attached. Now next option is I can move bromine to one more side on the left. So what will happen? Bromine to here. So what will happen if I am counting 2 bromo, 3 methyl? So let us see. I have moved one more side. I have written the opposite direction, CH3 and Br. So what will be the naming? 2 bromo, 3 methyl butane. So if I am counting from this direction, bromine will be the lowest. If I am counting from this direction, methane will be the lowest. If I take this sum of both counting, it will be the same. So which one will I choose? I will choose. So again I will tell you, that is, if I am counting from this side, 1, 2, 3, 4. 2 branches, carbon having branches are 2 and 3. So if I add their sum, it will be 5. On the other hand, if I am counting from this side, 1 dash, 2 dash, 3 dash, 4 dash. Just to differentiate between the numbers, I have put a dash in every case. So if I am counting again, if I am taking the sum, it is 2 dash plus 3 dash with branches. It is again 5. So in both cases we have 5. So which one will I choose? One with the lowest alphabet, that is bromine, will get lowest number. So 2 bromo, 3 methyl butane, and the carbon attached to the bromine is a secondary carbon. So these are all the isomers. There is no other isomer possible. 8 isomers. Among this has a unique nature or unique behavior. Unique behavior is that the skeleton that I drawn here has no other isomer. There is only one bromine in this case possible. One isomer of this skeleton, not the molecule but this skeleton. With this skeleton there is only one molecule of bromide or haloalkanes possible, mono haloalkanes possible. Okay, so that's all about the naming of mono haloalkanes. In the next part we will see the naming of dihaloalkanes. Thank you.